Hello, everyone, and welcome to the Deep Engineering Podcast, where we bring you real world insights from the engineers, architects, and researchers shaping modern software. I'm Sarkit Jha, Editor in Chief of Deep Engineering. Today's session was recorded live, and in this conversation, we'll focus on C and real systems, where performance, binary size, and maintainability all matter at the same time. The session ran for about an hour, followed by a short AMA. Due to a brief technical issue at the start of the original recording, we are reopening with this introduction before jumping into the conversation. I spoke with Sándor Dargó, Senior Software Engineer at Spotify, where he works on large-scale C++ systems with a focus on keeping code clean and maintainable over time. He's also very active in the C++ community, writing, speaking, and sharing practical insights. And you can also check out his blog at sandordargo.com. All the important links and resources from this conversation are in the description below. If you enjoy conversations like this, subscribe to Deep Engineering newsletter at deepengineering.substack.com. And with that, let's jump straight into the discussion. Thank you again, Sándor, for joining us today. I just want to launch directly into C++ 26 in real systems now, where I can just ask you about the smaller segments based on features. So when you look at C++ 26 feature set from the vantage point of a staff engineer who is probably responsible for a large code base, which 2 or 3 features do you expect will most change everyday design decisions over the next 5 years, and probably why?
Well, first of all, thanks again for having me here. It feels like what's going to change thanks to C++ 26 over the next 5 years. Well, I'm not sure if a lot will be changed over the next 5 years, but everyone is get back to that later. But if I had to pick a few features, well, definitely everyone is talking about what do they talk about? We're talking about contracts and reflection. That's going to change everything. I'm not sure about the time scale though, because look, if you look at C++ 23 support, even that is not complete yet. Especially if you look at the differences across compilers. Like you go on C++ reference and you check what's implemented on which compiler, and we are simply not there yet. So given that time scale, I'm not sure about the answer.
Yeah, I mean, you did mention reflection and contracts. I mean, a lot of engineers hear that. So new async execution, machinery, and think more power and more complexity. So let's say if you were reviewing an architectural proposal that leans heavily on these features, what are the first probably red flag questions you would ask?
I don't think I could hear you well. You said the red flag.
What are the red flag questions you would probably ask? Are you able to hear me, Sándor?
Yes, I can hear you now. Sorry, I think there's a problem on my side now, and I lost you. Yeah, okay. Sorry, now I hear you well. Can you repeat the question, please?
Yeah. So a lot of engineers hear reflection, contracts, new async execution machinery, and think more power and more complexity, right? So if you were reviewing, let's say, an architectural proposal that leans heavily on these features, so what are the first red flag questions you would probably ask?
Look, it depends on the environment. If I assume that we are in a widely used production environment, and these are very new features, I'd probably ask if those approaches are actually proven to work and how maintainable they are. Because for the time being, I think we simply lack the experience with these new features. Often we try to discover how to use them properly. To be among the first adopters, it's sometimes good. Sometimes it's better to be in the second line. I would say it really depends on the environment. But I would look for already proven maintainable usage if I saw these features. That's pretty much like what's happening with almost like all new major standard versions. Like there are people coming like, could we use this? Can we use modules? And well, And you often end up saying sadly, no, it's not possible because we are simply not there yet. There is no cross-platform support for that, for example. But I can imagine that will be the case for reflections for contracts in the first years. I know if today you go on CPP reference, you'll see that it's simply not implemented yet.
Interesting. Also, most teams don't upgrade to C++26. They incrementally adopt features inside long-lived systems. And so to you, what does a responsible adoption plan look like for a big feature, say contracts or reflection? And probably where would you pilot it first, or where would you explicitly, ban it until you've learned more?
No, that really depends on your environment because, for example, if if you target one platform, you know which compiler you are using. You might say that, okay, it's supported on my compiler. It was shipped as ready. You can go ahead and try. But if you have to support different platforms, if you have to compile with different compilers in the same pipeline, you first have to check if all the different compilers are supporting that properly. And know that in some of my earlier environments, I simply couldn't start using even C++20 for a long time because not every feature that we needed was supported on all the different compilers. But at some other teams, we said, okay, we use this compiler, it's shipped, let's go for it. What you have to make sure is that even if for some reason you have to fall back to the previous version of the compiler, which I guess you would know in a few days or few weeks. Let's say with few weeks. You have to make sure that if you fall back to the previous one, the previous version, you still don't have to change your code. It would be quite a pity that you move to a new version and then, oh, okay, let's start using, I don't know, concepts from C++20. And then in maybe in 2 weeks, they say, well, okay, there is a problem. We must go back to the previous version. And they say, okay, but it's not that simple. It's not just updating our environment, the compiler version, because we actually have to change the code. So I'd say, yeah, check that one as well, that you have a safe fallback plan.
I do have a question around that, which I'll bring on stage later. Someone's asked a very interesting question, but we'll wait and bring that question from Rupam later. I want to ask also about the gap between what the standard offers and what compilers, libraries, and tools make practical. So, from what you see today, where do you expect the gap to be widest for C++26, and how should probably engineering leaders factor that into their roadmap?
Well, I think the gap will be the widest where, but the feature is completely new because sometimes you just see that, well, okay, there are some additions to the library or just some very simple changes. If I think, what can I think about? Like there is std spam. Think with C++26, it receives the at member function, something that is just a simple addition, and it was there for rather under containers and container-like objects. That will be there. Won't be any gap there, I think. But if you think about contracts and reflection, the big ones, maybe different vendors started their work early on and they took different approaches. There might be a bigger gap, just like we saw with C++20 modules. I hope though that it won't be that that problematic. But I don't know when I would be able to use those in a production environment. I don't see it in the next 1 or 2 years. I hope I'll be wrong, but
Imagine yourself probably as a chief skeptic in a C++ organization where one C++ feature you'd be most worried about people misusing in the first 2 years at least.
so I don't think I understood the second part.
Would you be skeptic about a feature you'd be most worried about people misusing in first 2 years for C++26?
Should I be skeptic about new features that they are getting misused? Skeptic, not maybe, but cautious, definitely, definitely cautious. Is well, if it's so new that reflections and contracts, we have to learn how to use them properly. And I guess the best thing will be is not just keep adding new code to the code base without too much afterthoughts, but really to walk through like why we use them in a certain way. Not to be picky and not to be skeptic, as you said, but really just to to share the knowledge in the team, because there are always people who are early adopters and they really enjoy that. Now we can start using this. I say I'm among this group, but you cannot just push the new way of coding. You you should share the knowledge and discuss what actually these new features bring. Because if they only bring well a different syntax, that's not really good. If they actually solve a problem in your code base, in your use case, then it's good. And let's discuss why and how that's the right solution. I'm not saying that with this you should do with every pull request all the time, but definitely when it comes to these new things, because I'm sure that deep down everyone wants to learn about these, and we all want to start using them as soon as possible.
We do have interesting questions coming your way. So, in fact, they are about the things that we're going to talk about now. But I'll just bring them on stage later. You guys can keep posting the questions. We will bring them later. Thank you for posting those questions, Olo and Sahil. I want to ask now. Yeah, let's just talk about clean code versus performance versus binary size. In fact, you framed talks with titles like "Clean Code, Horrible Performance." Like, could you please give us some concrete example where code that looked cleaner or more idiomatic C++ ended up being a serious regression in performance or memory, and probably what the team learned from that?
The title of the talk was a question, provocative one. Someone very active in the community told me that you shouldn't have said that. You shouldn't have said the title because it's misleading. Well, maybe it was. Yeah, it was a provocative question. My answer is no. Clean code doesn't imply horrible performance. No, I cannot personally bring stories from the opposite. Now, like we must admit that there are some constrained environments and some cases where on the hot paths you must optimize for performance and forget about readability. Otherwise, your software will just not meet its non-functional requirements. I think maybe the most well-known example for that is how square root function was optimized for, I think, for Quake 3, or I think it was Quake 3. But in my experience, even in environments with a very high throughput, readability and maintainability gained through clean code was always more important than optimized performance. Wherever I worked, network latency and database read times, and not to mention database write times, they dominated. At the same time, I've seen people optimizing for heap allocations, let's say, that, oh, we shouldn't allocate for a string there, but at the same time, they were making network requests in a loop. And it just doesn't make much sense. I think if you want to make your software more performant, you shouldn't forget about Amdahl's law. He said that, well, I have to read that the overall performance improvement gained by optimizing a single part of a system is limited by the fraction of time that the improved part is actually used. And this might mean several things, but I want to just mention two things. One is that you can often ignore slow code if it's not on the auto. That's probably the obvious meaning. But there is another take of this slow, is that slowness is relative. If your code takes a long time to execute due to network latency, and relatively speaking, a heap allocation is not so slow anymore. So I'm not saying that you should just put everything on the heap. No, I'm not saying that. Even in a latency heavy project, not at all. I'm just saying that don't worry about things that don't really matter in a given environment.
Interesting. So you answered one of my questions, but I'll still ask the follow-up question I had in mind. Senior engineers and architects often have to give global guidance like prefer X over Y, avoid pattern Z. So if you had to write a one-page policy for a large C++ code base on trade-offs between readability, performance, and binary size, what would be on that page?
If it's a one pager and you don't know the environment, you don't know the exact non-functional requirements of that system, probably that would be language agnostic. It wouldn't really be about C++. For me, the number one point would be is the default to readability. You still read code more often than you write. Well, not to mention the agents, but they also prefer simplicity, I think. So second would be, well, default to readability, but if you have to optimize, measure first. Don't start optimizing for performance or for anything, for the matter of fact, before you prove that it is actually a problem. You don't optimize just because you can. You optimize if you need. Because otherwise you just waste time. Reverse, you think you optimize the necessary while you don't touch the real problem. So measure first and optimize after. Optimize only the hot path. Well, probably you will find that with the measurements. So you keep the hot path isolated and well documented, and that will help you later when need for maybe for more optimization emerges, and definitely document why you do certain things. When it comes to, for example, to binary size, okay, be aware of the trade-offs, like templates, inline functions, or heavy type erasure might cost you too much. It doesn't mean you have to avoid them, but you have to understand the language and your constraints. Maybe you just don't care in a given environment with these things. Last but definitely not least, make the trade-offs very explicit in code reviews, but not only in code reviews, but in the code itself. Commit some comments. If you sacrificed the clarity that we aimed for at the with the first point, well, document why. Because otherwise, someone later on will come in and think, okay, that's not very clear. Let's make it clearer. Why they are unaware of why certain choices were made. I've been there. I've done that. I can okay, this doesn't really make any sense. And like, well, but actually it does because it slightly changes the binary size, and we need that. So okay, let's go back. But it was a bit too late. Some pull requests were already merged. So yeah, so I think that trade-offs, there will be trade-offs, but make them conscious and share the knowledge. And that's probably even more important in this new world of agentic coding. Because well, if you are in a team that doesn't change that much, I mean, people will come and go, but they share the context, they share the knowledge with each other. Maybe they talk to each other. Still, even in remote work, that might happen. The agents will not know that, so you have to have those things written, and preferably in the code base, because that's what they can read, and that's what you will read if you try to go in and see what to improve.
It's good that you mentioned binary size in this and also code review, but I do want to ask a question, though you slightly answered it. From your work on probably reducing binary sizes, what are the most common silent killers that creep into C++ systems over time? Things that probably show up later, months or years later. Yeah.
I think, well, that's a very broad topic, and I think that people can be very opinionated on it, rightly so. And I don't remember exactly when, maybe 2 or 3 years ago, I wrote a series of articles, and I also had a workshop at CPP on C on the effects of, let's say, programming styles on binary size. And I made it very explicit. Those articles and the workshop was not for embedded engineers because they operate on a different scale, and they care about different orders of magnitude of binary size changes. So there are environments where every single byte matters, and to make it very clear, I never worked in such an environment. But there is the other end of the spectrum where you might have to think about, bear with me, hundreds of megabytes. I know many of you might laugh or roar now, but I'm not kidding. In my career, when I first heard about the problem of binary size, it was due to a common library that or services shared, and it had to be present on servers in just too many versions. Like we had, I don't know, we hosted like maybe 2 dozens of services on that server, and there were a few that changed almost every week, and there were some others that barely changed in a year, and we had to keep I don't know, like 10, 12 different versions of the same library. And that library was more than 100 megs. So in that case, just by making sure that all the services get the new version of that library every few weeks, and we don't have to store more than 2 or 3 versions of that big library on the server, it solved our binary size issue back in time. No, maybe it was like 7, 8 years ago. And so we saw like 2 different ends of the spectrum, and there is another area in between, because you might work in an environment where you rather care about like kilobytes or maybe a little bit more, but let's say kilobytes. And if you go far, you go deep, you might even gain, a few megabytes. And I worked more in this domain, so I could probably mention a few silent killers from there. I would say is first one is unoptimized usage of compiler and linker settings. You might gain the most with those. I remember that we tried many different changes in the way we program, and that was very interesting. That was the most satisfying part of this project. As a programmer, like, you had a pull request and, look at the few kilobytes that we just shaved off from our binary. But then you change some settings and maybe half a megabyte is gone or even more. And well, that's just great. And it's all potentially often overlooked. But if we have to mention the ways you program how they might be silent killers or very effective, well, think about wide and irresponsible usage of overuse of templates. Like we had a framework where just adding a new object to this framework without any logic whatsoever, only with a boilerplate, due to that heavily templated architecture, it already added like 20 kilobytes for nothing. Well, we moved away from that. Unnecessary usage of stud function can be often problematic, and I would say a silent killer. If you don't need it, you don't need the capability of it, don't use it. We have our own backport of move only function from C++23, and that can help quite a lot. And I think people would complain if I didn't mention exceptions. That can be a not so silent killer of binary size, but you often cannot move away from exceptions, or it would be very costly. Well, I'm not very knowledgeable of the work, but it's CPPCon 2024. There was a talk by Kelly Lestel, who managed to reduce C++ exception sizes, I think by almost like 90%, when it was trying to optimize them for smaller firmwares. So exceptions, yeah, they can be problematic, but there might be a solution.
Interesting. By the way, just quick note for everyone, I have shared some article links from Sándor in the chat, which is above Q&A. So check Sándor's website. It's quite interesting. We've got some very good blogs from 2023 over there. I've shared some links, but please explore on your own the links that would be most relevant to what you're interested to learn about. Quickly also about a code review. Engineers often argue from taste, this is cleaner, or they might say this is over-engineered. So what practices have you seen that move those conversations from taste to shared criteria, so the team can agree on when a performance hit is acceptable and when it's not, probably?
Mm-hmm. Yeah, that can be problematic, and often it really depends, on the on the team. You have many strongly opinionated people. It can be difficult, but I think arguing over taste is never really a good investment of your time. I'm not just talking about engineering here, by the way. So you need to move from taste to agreements, and in order to do that, you have to communicate, you have to talk, and eventually you have to decide. And well, it might not be a very popular that I'm going to say. You have to decide, but not necessarily in a democratic way, because your workplace is, well, it's not a democracy. Certain people have more to say based on their experience and also based on their responsibility. But what's important is that eventually you should introduce some shared decision frameworks. Well, that's a big word. I mean, some coding guidelines, or maybe maybe you should track binary size in the CI pipeline, so you see the effects at the end of a build. Maybe you need to track performance metrics. It really depends on what matters to you. But once you have numbers, the conversation is not about taste anymore. Also, well, you cannot quantify anything. So, like the coding style, if it doesn't really impact neither the performance or the binary size, or you just don't care about those things, then maybe, common practice helps. Like you can have coding dojos internally, and there you can try and discuss different ways of doing things, and explore those trade-offs without delivery pressure. So you explore, you discuss, and you can move from phrases like, I like this more, I prefer this, to, well, that's actually the style we agreed on. So let's just keep discussing and try to set some common guidelines in the team. If you can have the time to practice together or educate yourself together and share what you learn, that's even better. And measure what matters to you.
Yeah, that's a good advice. We have 20 minutes left in our conversation. I just want to make most of it. So let's just spend some time talking about time, clocks, and observability. C++. You've actually also been writing a detailed series on time in C++ and the different clocks and chrono. So, question I want to ask you is, in real systems, what are the top 2 or 3 mistakes? Mistakes probably you have made, or probably you've seen other people make when working with time, probably like choice of clock, convergence, or yeah, and probably also how they wire into logging and metrics.
Try to keep everything in mind. Feel free to remind me. So, common mistakes. Well, probably the most common mistake is choosing the wrong clock. Maybe maybe you don't understand the different guarantees, the different advantages of the different clocks. And for example, instead of using steady clock for for measuring small intervals, maybe for a retry logic, you will take system clock to measure that latency. Then you later, due to some bugs, you figure out that, well, actually that's not a monotonic clock. It can jump backwards due to adjustments or manual clock changes. So that's definitely one sort of issue that you might run into. Another problem that you can easily have is about unsafe conversions and cross-system time, because, well, I would say time is relatively easy when it's in one system, so you have to know what clock to use and when. But when you have different systems, different platforms, and you end up with different clocks using different epochs. Clocks have same clocks, samely typed clocks have different precisions or time sources. Then that becomes very problematic. Well, there you will have to debug and see what exactly is going wrong. But whenever you try to compare or convert times from different systems, be very cautious. and test with all the different platforms, test manually as well, debug and see what's going on there. And well, if you still use C-style APIs, things go wrong easily because they don't give you the time safety, the type safety that chrono durations give you. So that's definitely something to think about. It might be that well, you must use some C-style APIs. You cannot get around that. But try to isolate those parts and do the conversions on the boundaries and within what's within your control. There you should rely on modern time representation. So use Chrono wherever you can.
Good that you mentioned APIs. I do have a question around that. Now, for some senior engineers designing APIs and libraries, how do you like to expose time in public interfaces to do it? Which clock sites set to build APIs, and where do you insist on abstraction layers or custom clocks to keep things testable and observable?
So try to use Chrono instead of C-style APIs and avoid raw integers and do use, yeah, I said that we use chrono durations and time points. Also, unless it's really necessary, try to avoid exposing the concrete clock types. But if you need to, you need to. And remember that when it comes to latency, then you should prefer steady clock and make sure that that is communicated well. What's also important when it comes to time and APIs is that you keep your abstract enough so that they are testable. You can test. So you don't. Let's make it very specific. You don't rely on the system clock, but you can inject the time provider, and then you can test different assumptions that you have regarding your code. Keep that injectable.
Good. Interesting. In fact, we do have a question around that as well, which I'll take up in next 15 to 20 minutes. But let's just quickly move and talk about scaling C++ expertise and learning culture. So we have a lot of people here. I'm sure they're interested in some of these questions. You run a daily C++ interview and you've been blogging for years. What has this consistent teaching and question writing shown you about real gaps, even when experienced C++?
That's a very interesting question. I would mention maybe two main things. One is there is a sort of a depth gap. Well, just think about it's a massive language. The standard is how many pages? It's about 2,000 pages long. And well, that's just big. So what I want to say is that even if you are an expert in one area, it doesn't mean that you master all the other categories. So, for example, you might be a master of template metaprogramming, but maybe you don't know anything about multi-threaded programming. The best practices, idioms, practice can be quite different even in different industries. It's certainly different in like big enterprise architecture and in low frequency trading or game development. And I think we should be humble enough to acknowledge our boundaries and say that I don't know. Or I say I never worked with this, so I won't be able to give you a good answer. And I think in the beginning of your career, it's quite natural to acknowledge this, and also probably when you have decades of experience, because you are confident enough to say, I don't know that area. But between the two, it's more difficult. And I think the sooner you can make this shift, the sooner you become ready to say that I don't know this topic, I don't know this field of C. It will be for you even in interviews. I remember I said in an interview that, okay, I don't know anything about that part. I could guess, but I don't want to. And they accepted that. They said, well, actually, we don't really use this either, so let's just skip. And I got hired at the end. So I think honesty is important. But there's another interesting thing I noticed during interviews, for example. So this other gap is about fundamentals. I've seen many senior level engineers who were really good at architectural questions. They were good at talking, explaining, but they had difficulties writing some very simple algorithms. And I'm not talking even about like, medium or hard, difficult lead code problems, but simpler ones. And they sometimes you cannot prove your fundamental knowledge under pressure. And to be clear, I'm not a fan of lead code style interviews, but you do have to be able to solve some issues live with someone watching. So I think even if you don't like it, you have to invest in yourself just enough to be comfortable in such situations. And that's something that you will not learn on the job. Something that you have to practice, I think, on your own in your own free time, probably. If you practice for interviews, so that's probably meaningful to practice in your free time for that.
That is a very good advice and edifying. Thank you. I have questions, but I think I'm going to skip asking those questions. Maybe I'll circle back later and ask the questions if we have time. Because we have some questions I think will take some time for you. So I think right now let's just move to MA session and I'll just show the questions on stage. Let me just bring the question from.
Okay.
Yeah, there's a question which is an interesting one.
Let me make it a bit bigger. Okay.
That'll be helpful. So can you share more about exceptions? What's your opinion and what you would use STD expect instead or plain other tools? Second question also there's what about the compilation time after including the STDL into a lot of headers, for example, STD string?
So what's my opinion about exceptions? Would I use to the expected instead or plain error codes? Well, I would use probably I would use both exceptions and to the expected. I would probably move away from error codes, even if I don't have access to plus 23. To the expected is something that's quite easy to backport to earlier versions. That's what we do at Spotify, for example. We have our own backport of stud expected. There is nothing fancy in it, and it's just a more expressive way to return either a value or an error code. I wouldn't necessarily replace exceptions with them. But it really depends on your context. I'd say is if you cannot afford the cost of exceptions, which is a good question. What those costs really are after the works that I mentioned, then yeah, use to the expected. But otherwise, you use to the expected maybe for error codes that you really expect to happen.
Mm-hmm.
And you use exceptions for exceptional cases. I think even semantically they serve different needs, but you might end up in a situation where you just not allowed to use exceptions. But usually that's not your own decision. The compilation time that will depend on your needs, on your non-functional requirements. I would say I personally don't have really big problems with compilation times. I have way more problems with how much time testing takes and also their reliability. But I hear you. I've seen people who complain that it just takes too much time to include standard library everywhere. And I think recently, maybe in the last few weeks, Vittorio Romeo posted an article about this, that in certain environments, I really hope I quote him well, or I mentioned the right thing he said, where he just tries to avoid using the standard library because it makes a compilation time too slow for him. But again, this will depend on your requirements and your environment. For me, that's barely an issue.
Interesting. We do have another question that is related to this one. So I'll just show this on the stage. I'll mark this one as answered.
Where expectations have shifted for senior staff engineers compared to 5 years ago.
More on the thought leadership side.
Sorry?
That's more on the thought leadership side.
Yes. It's a good question. Well, the language is obviously changing. So that's there are two parallel shifts, I would say. One is that the language itself is evolving and changing. It's 2026. I just make it 6 years maybe. So we got 3 new standards, and I think that a bit less template meta programming wizardry is required now because of concepts and how it changed the way we code. We talk way more about safety in C++ than before. I think before we only focused on not only, mostly focused on performance, but that's clearly changing, and safety is also become a main topic in the industry. You can also see that in the different proposals the committee gets and accepts. But that's just the language level shift, because there is this other shift over the last I don't know how many years, maybe a year or 2 years, that we are relying on LLMs and agent encoding more and more.
Yeah.
That's definitely where more and more are expected from senior and staff engineers. It's as if like you've become a team lead of agents, and you keep giving tasks to them, and you keep reviewing the code, and also to tune your questions. I didn't want to use the word prompt, but basically that's it. So I think as a senior staff level engineer, you are expected to be professional in agentic coding. One would even say be AI first developer.
Good. Interestingly, we also brought Victor, who asked this question on stage. Victor, would you like to ask any follow-up question you might have? Feel free right now. The floor is yours.
Hello, can you hear me?
Yes.
Yes.
Hi, Victor.
Yes, hello. Well, my second question regarding this was towards the AI shift that's happening for all developers. I think you answered that a bit, but maybe you can speak some more about it. Thank you.
Thank you, Victor.
To speak more about this AI shift, I'll tell you something. I think as a developer in this new world, you have to learn to like your job again, or still, because before, what was it like? You get your tasks maybe at the beginning of a sprint, or just a week, or whatever. Then you went back and started to explore a bit, read more about the requirements, explore the code. It took some time for that. Maybe you started by writing some tests, maybe to write some simple code and step through the debugger, and you slowly built up the models in your head and thought about the different kind of solutions. You might even enter the so-called flow, which requires focus and a bit longer time. And I think we kind of lost this over the last few months, and we became often just prompters. And many of us complained even before that we are living in a world of constant context changes, and it's very difficult to keep up. But it just became even worse, because at the same time, most probably, you will try to prompt different agents with different problems at the same time, and you keep jumping from one window to another, maybe from one meeting to another, because others are also moving faster, or at least they think they move faster. We could talk more about that. Basically, you lost everything, or maybe almost everything that you liked about your job. But we have to adapt somehow to this new situation. That's something I think it's mentally it's very difficult, and it will still take some time, because you can read or hear about people who even left companies where it was mandated to become a so-called AI first engineer because, well, they just don't like it. I understand why they don't like it, but there's a fair chance that there will be nowhere else to go, so we better adapt. I don't know where this leads. I read something very interesting, I think yesterday on the Pragmatic Engineer. It's a great Substack if you haven't known it, and they quoted some research paper where they said that, well, it seems that in the beginning you ship more code because it became so much easier, but you don't just ship more code, you ship worse code, and that gain in speed is vanishing after a few months because you start accumulating tech debt at the same time. What first seemed faster becomes not faster, but the tech that stays. So I think we are quite in the beginning of this, and this shift is happening very, very quickly, and we don't see yet where it's going. But we have to think about it a lot, I think, and we have to try different approaches of how to adapt to it. I also try different ways of working with these agents that keeps me happy, but also tries to speed me up. It doesn't remove what we like in this job, but actually helps. It's difficult. It's difficult, and I'm even happy to continue this maybe over mail or different messages after if any of you have some views on this.
Thank you. Thank you for answering that for Victor. Let's just take a new question. I will bring a question about large scale consideration on stage. All right. So, question from Follow about at large scale, what considerations should be in place for build systems aimed at this?
I'm not sure what Paolo had in mind regarding those considerations. I give you one example. You don't necessarily only think about how you can build your plus system. That's important, especially if we talk about C++. But you might want to think about how you integrate that into the bigger picture, because you might want that the same people can easily work with building different applications. So, for example, you might want to build for different platforms. You might want to build for iOS and Android at the same time, and you are looking for a build system that can easily take care of everything. This won't be necessarily the case for everyone, obviously, but it might be one. So if you are on very large scale and you have to take into account different platforms, different languages, you might look into Bazel, which helps reducing the overhead you might have if you use some other build systems like CMake, for example. I think now your mic is a bit strange. How to deal with the binary size increase due to the LTO link time optimization flag, which optimizes performance. So I said earlier that you should be able to say that I cannot answer this question from the top of my head. I would have to dig a bit deeper, and probably it involved a lot of measurement and different trials of different flags with different values. So, but if you connect on LinkedIn, I'm happy to follow up there in the coming days.
Great. I'll just bring one more question on stage. I'll let you read it.
So what are your thoughts on adoption of new C++ features like transform or ranges versus friction with code readability and familiarity? Like using to-transform syntax may reduce boilerplate, but will be less familiar and difficult for most reviewers. I think that's an excellent question. Yeah, I think that code familiarity shouldn't really be a problem. Yes, there will be people who are not familiar yet with these new features, but these features, they don't just come and go. They come and they stay, especially in C++, where it's so difficult to remove anything from the language. So I don't see that a problem. It's actually a way to teach about new features, but code readability, that's a different question, and that's something that might change case by case. So often, I see a loop and I think, okay, could we use some algorithm here? Maybe even ranges. And you might say, yes, okay, let's try it. And you try it, and you realize that, well, it became more modern, but actually it's less readable, and not because of familiarity, because, well, you introduce it, you're familiar with it, it's just less readable. So if it's less readable and it doesn't bring any value, it doesn't make your code, safer, smaller, faster, whatever, it you just use something new, well, then just drop it and keep using what you used. But that will go case by case. Sometimes, if I'm not sure, I ask a few of my colleagues, okay, here's a small pull request, only of this change, or maybe not even a pull request. You just share the code on Slack. And so, what do you think? Does it make it more readable, or is it just a waste of waste of effort? And yeah, it will go case by case. So long story short, I wouldn't worry about familiarity, but readability, yes.
We do a question added as well.
Any logging library suggestions for low latency systems? Binary size doesn't matter. Sorry, no. Wherever I've worked, we used our own.
I'll mark that as answered.
That will be a quick one. No. What about caching iterators in ranges filters? Because filter view are memoized sometimes. I'm not sure what this question would be about.
Okay. I will then. Oh, the question. Victor has a question.
Why do you not use Boost ASIO exactly? Well, it's not needed in my domain, I would say, what the capabilities it provides. So that's the easy part of the answer. There is another part. We try to minimize our dependencies on Boost and any external libraries. That's just a policy we have.
Okay. I think we have one more question. It's about C++.
Many C++ jobs are taken over by Rust. What's your view on that? I'm not sure how many that is. Like I had C++ colleagues who fell in love with Rust and they moved to other companies just to be able to use it. I don't necessarily see that as a huge threat. I don't think that Rust would go away anytime soon, simply because, well, it's an old language. It's an old and evolving language, and we have plenty of systems out there which you will just not replace by anything, even if C++ is not needed for the domain, because the cost of replacing and the risk of replacing it is too high. I'm sure that if you think about, the pool of jobs, of engineering jobs as a pie, then Rust has a bigger and bigger slice in that pie, for sure. But I also think that the pie itself is growing. So we have more and more jobs for engineers. And even if there are C++ jobs taken over by Rust, the overall number of jobs are growing. And at the same time, I also think that, again, it's a bit early to clarity on this, but I think that moving beyond different language limits is becoming easier and easier, because you can have quick insights on a code base with the help of agents, so you don't ask it to change things. but you ask it to explain what's happening and why. And even moving to a different language will probably be faster than it was before. But, even about C++ jobs, I'm not worried. There are even COBOL jobs out there still because banks just didn't move away from COBOL for very old systems. So you can actually make quite good money, I think, if you only know COBOL for the time being. And this actually reminds me of a story of an excellent colleague I had back in time. My previous place, we're moving away from IBM mainframes. It was a huge project. I think it lasted over a decade. And when it finally ended, we asked him, I think he was called John, what are you going to do now that what you knew about so much is gone? What will I do? I'll also go somewhere else where it's still needed.
C++ has a great fear.
Yes, I think people are already talking about C.
In fact, I would take this moment to also say that we have been plotting a newsletter in coming months about low-level engineering, and we'll be mostly covering a lot of things around C++. So please do subscribe to Deep Engineering. We do feature leaders like Sándor who talk about C++ and do events as well. There you will get to know when we will launch that newsletter in coming months. We'll move to asking another question. It's on your screen.
Where do you draw the line between using modern C++ abstractions and avoiding them due to performance costs? Well, I think that, but again, I wanted to say that it will depend on your domain. But often there are abstractions that are almost as fast or just as fast as the old unsafe counterparts. But often people don't use the good abstractions. Like many people will say, "Oh, okay, I'm using row pointers because, well, shared pointers are so slow." And probably the people in this audience, they like, well, but it's nonsense. But you are here, you are investing in yourself, you are investing in your professional growth. And you see otherwise, it's often like people just default to use shared pointer, for example, instead of default to unique pointer, which is fast and cheap. And they would just complain sometimes that, oh, but by the way, it's so slow. So often you don't really have to draw a line, but you have to know what exactly to pick and don't just default to the easy one. But then again, when it comes to performance, you have to take into account your non-functional requirements because performance is not for the sake of performance. You don't write faster code so that it becomes a bit faster. You write faster code because you need it. And if you don't need it, and then you default to readability, you default to safety. And if you work in an environment where, as I said, like a network latency or discrete latency dominates, then you will not care so much about the cost of an allocation on the heap, for example. But just out of curiosity, I also made some measurements on ranges, for example, and I know that the early versions of C++20 ranges were not necessarily as fast as using a for loop or using the C++11 counterpart, some algorithms where you have to pass the pair of iterators, begin and end. Is that a problem? Well, it depends on your use case. If that's so slow that you can't take it, you don't take it. But otherwise, just don't worry about it. At least that's how I see this. This reminds me of a project where we had to scale to like 10 to handle 10 times of the requests that we used to get because we got a new client, and there were many problems to fix. None of them was about modern C++. Actually, I think in order to meet our new requirements, often we we had to move to modern C++ features just to guarantee the safety that they bring.
Interesting. I think that brings us to the end. I know earlier you did talk a little bit about cognitive load because of context switching. And I think the tips that you mentioned, you highlighted over there were quite helpful. In fact, in next week, we'll be having an article around that, putting more emphasis on developer productivity over developer experience. Because mental fatigue is a real thing that engineers face today. So thank you so much for highlighting that and also answering these questions.
Thanks a lot for having me, and thanks for all the questions.
Quick note. Thank you everyone for joining us today and for your patience also in bearing with us through the technical difficulties earlier. So we'll be sharing a follow-up article as I mentioned in this session, and a recording will also be made available when we have edited it. Also, we done quite a few C++ sessions like this, and Mansi, my colleague, would have shared that in the chat. Feel free to check that out. And if you haven't already, do consider subscribing to Deep Engineering. I'm the new editor-in-chief for Deep Engineering. I hope not to disappoint you. We send out a newsletter every Thursday with insights from experienced engineering leaders like Sándor. Practical things actually you can apply at your work along with different industry perspectives. So thanks again, and we'll see you in the next session. Thank you, Sándor.
Thank you so much.
Hello, everyone, and welcome to the Deep Engineering Podcast, where we bring you real-world insights from the engineers, architects, and researchers shaping modern software. I'm Sakit Jha, Editor-in-Chief of Deep Engineering. Today's session was recorded live, and in this conversation, we'll focus on C++ and real systems, where performance, binary size, and maintainability all matter at the same time. The session ran for about an hour, followed by a short AMA. Due to a brief technical issue at the start of the original recording, we are reopening with this introduction before jumping into the conversation. I spoke with Sándor Dargó, Senior Software Engineer at Spotify, where he works on large-scale C++ systems with a focus on keeping code clean and maintainable over time. He's also very active in the C++ community, writing, speaking, and sharing practical insights. And you can also check out his blog at sandordargo.com. All the important links and resources from this conversation are in the description below. If you enjoy conversations like this, subscribe to Deep Engineering newsletter at deepengineering.substack.com. And with that, let's jump straight into the discussion.